Hi everyone, welcome to my channel. Today we examine Pakistan's massive 500-kilometer Kachi Canal project.
Water is diverted from the Indus River system using gravity, without relying on engines or turbines.
The engineered channel stretches through unforgiving terrain, bringing vital water to the arid regions of Balochistan. Engineers first established precise survey lines across scorching plains, using optical total stations and level rods.
Vale, un poco más a la derecha. Aquí está bien. Sí, perfecto. Fija la estaca.
Every elevation change is studied meticulously to ensure water flows smoothly without eroding the channel banks. Workers clear vegetation and level the corridor to prepare the ground for heavy earth-moving machinery. Bulldozers scrape away topsoil, creating a smooth, stable surface along the entire canal alignment.
That last bucket seemed a little light. Confirm the volume on the tablet.
Hold on, the sensor reading is coming through now.
Motor graders refine the sloped canal banks to achieve the precise angle needed for structural stability. Heavy rollers compact the subgrade soil, creating a solid, uniform foundation for the concrete lining.
Field workshops provide equipment repair and fabrication services to keep heavy machinery running continuously.
Excavators dig deep into the earth, cutting out the trapezoidal prism of the canal channel. Operators carefully trim the side slopes to ensure a consistent cross-section along the entire length.
Multiple excavators work in sequence, excavating deeper sections while maintaining exact slope geometry. Excavated earth is hauled to build raised embankments that protect the canal from overtopping during high flows. Trucks deposit compacted soil along the canal edges, forming protective levees and service roadways.
Excavators continue refining the canal walls, removing loose earth to prepare for concrete lining installation.
Workers prepare a structured foundation pad, where key hydraulic structures will be integrated into the canal.
A layer of granular aggregate is spread over the subgrade to support the heavy concrete lining.
Vibratory rollers compact the gravel bedding layer, ensuring a stable and well-drainable base.
Excavators clear final debris from the canal floor ahead of the lining placement process. Graders smooth the top of the raised embankments, forming a stable service road along the canal. Survey teams verify channel dimensions with leveling rods to ensure precise concrete lining geometry. Heavy rollers compact embankment slopes, strengthening the banks against erosion and water pressure.
Water trucks spray the dirt subgrade to maintain optimal moisture levels for compaction before concrete pouring.
Sheep's foot rollers knead cohesive clay soil layers, eliminating voids within the embankment walls. Motor graders perform final slope trimming, ensuring uniform side slopes along the entire reach. Water trucks wet the interior slopes of the canal trench, preparing the subsoil for concrete placement. Compactor rollers travel up and down the inner banks to ensure maximum soil density beneath the lining. Graders shape the outer slopes of the embankments to protect against external surface runoff. Bulldozers dress steep embankment slopes, creating a clean and uniform outer profile along the canal. Bulldozers and graders finalize the embankment profile, ensuring long-term structural integrity. Graders refine the inner channel slopes, creating a smooth surface ready for concrete formwork installation.
Fleets of graders work simultaneously along extended reaches to complete earthworks efficiently.
Engineering teams conduct final survey checks on the finished earthwork before concrete lining begins. Excavators dig foundation pits for cross-drainage culverts and water control structures along the route. Portable pumps remove accumulated groundwater from deep excavation pits to keep work zones dry. Graders and compactors prepare the subgrade for concrete culvert pads at cross-drainage locations.
Ready-mix trucks pour concrete to create a flat leveling pad for structure foundations. Iron workers assemble dense rebar mats to reinforce heavy concrete culverts against soil and water loads.
Move the hose to the left. Okay, bringing it over now. Keep vibrating that section. Watch your feet back here.
Excavators carve out cross-drainage channels to divert seasonal floodwaters safely underneath the canal.
Heavy concrete bases are poured for escape regulators that release surplus water during flood events.
Wooden formwork panels are erected to shape the heavy reinforced concrete walls of water regulators. Road bridges are constructed over the canal to maintain community connectivity across the water corridor. Twin-cell concrete box culverts are installed to pass natural drainage under the canal embankments. Excavators begin digging branch canal offtakes to distribute water toward agricultural fields.
Iron workers assemble rebar cages for branch regulator structures that control flow into distribution channels. Excavators dig parallel distributary channels to create the fine network of agricultural supply waterways. Concrete mixer trucks pour foundation slabs for twin distributary control gates simultaneously. A mobile crane hoists a tall steel rebar cage into place for a regulator gate pier column. Concrete is pumped into tall column formwork to construct sturdy piers for heavy steel gate hoists. Crews construct multiple concrete pier columns that will support the gates and operating platform.
Slow the flow. We're good here. Stop the chute.
High-strength concrete is poured for wing walls to transition water smoothly into the regulator bays.
Workers align steel gate guide slots within concrete pier recesses to ensure smooth vertical gate motion. A mobile crane lowers heavy precast concrete beams to form the walkway deck across the regulator bays.
Workers place concrete over deck formwork to complete the operating platform above the control gates. Crane crews lift heavy steel vertical slide gates and position them into the concrete pier guide slots. Technicians install motor-driven screw hoists and gearboxes on the upper deck to control gate elevation.
All right, keep that pour steady on the north side. Make sure the vibrator man is keeping up.
Heavy diesel backup generators are positioned to ensure uninterruptible power for gate operation during outages.
Electricians lay heavy power cables in elevated metal trays to connect control panels with gate motors.
According to the schematic, this blue one goes to terminal 12.
Right, and we can tie these back now.
Adjustments are complete. How does the readout look?
Solid green. Calibration successful. I've logged the data.
Solar panels and lighting masts are installed to power remote monitoring equipment and secure night operations.
Inspectors perform a comprehensive dry inspection of the entire canal lining before admitting water. Defective lining sections are marked, cut out with concrete saws, and re-poured to ensure zero leakage. Flexible elastomeric sealant is applied into cut expansion joints. This is to prevent seepage under thermal movement. The head regulator gate opens slightly, admitting the first thin sheet of water into the dry canal. Engineers monitor the initial low-level flow. They check wetted surfaces for seepage or joint instability. Water passes through regulator gates into stilling basins, where energy dissipators calm high-velocity discharge. Branch gates open, allowing controlled water volumes. to flow into secondary distribution channels. Field turnout gates release water from minor canals, directly onto dry, leveled agricultural plots. The 500-kilometer Kachi Canal stands complete, delivering life-saving water to turn dry deserts into fertile land.